So the first thing I'm going to do is give you a quick overview of the post-processing workflow. I currently have a part already programmed in here, and this is RhinoCam 2019. And as you can see, there are several operations that we have programmed in here, starting with roughing, pocketing, several different hole making operations like drilling, hole profiling, and then countersunk operations, deep drill, a few tap operations in here, and then profiling. So as you typically would program your part, you would go through the process of creating all your machining operations in here. So one of the things we would like to know is how do we post-process machining operations. So ideally, if you want to post-process the entire setup of operations that you've programmed, so you just highlight the setup, right-click, and choose post. Now, before we post process, we would like to make sure that we've selected the right post processor that would be compatible with the machine tool that you'd like to run this on. So to do that, you would go into the program tab and click on post. This will display your set post processor options dialog. And in the set post processor options dialog, you have the current post processor drop down where you could select your post processor from the list. These post processors are either listed by the name of the controller, or it could be the machine tool, or it could be like a combination of the control and the machine tool in here. There are over 300 plus different posts that are included in the standard library of posts. And you'll see that the folder where post-processor files are located points to the default location of the install path of the application in the app data folder. So if you're running RhinoCam 2019 in Rhino 5, this would be under program data Microsoft RhinoCam 2019 for 5, and then post and mill. If you're running Visual CAD CAM, it'll be under Visual CAM 2019. Likewise for Visual CAM for SolidWorks and a LibreCam as well. So by default, it'll be pointing to the right folder. The next thing we want to also make sure is our posted file extension. So if you look towards the bottom of the dialog, you will see a drop down for the posted file extension. Most of the common extension types are already included in here, like for example, .nc, .tab, .gc, or .text. This is the extension type that you want to set so that your controller can read those file extension types. Now, if your extension type is not on the list in here, you can select add new, and you can enter a new extension type. So for example, I could say I want to add .cnc as the file extension type. And then when you select OK, the new extension type is added, and it's automatically set as the current extension type, and you'll see it in the list down below. And you can always change it back to whatever the preferred extension is. Now, I will talk about the posted naming conventions in just a moment, and also the program to send the posted file to. So I'm just going to click OK to accept it. So what we've done here is we've set the current post processor, and we've set the posted file extension for the machine tool. Now, to post process all of the operations in a given setup, you can highlight the setup, right click, and then select post process. So when you select post process, this will post all the operations that are programmed in the order in which they have been programmed in here into the posted output file. So right click and post. This would display a post and save as dialog, and it'll automatically go into the last folder where you had posted to. Now, if you hadn't posted earlier, it'll automatically go into the folder where the document was located. But if you had changed it to a different folder, it'll always go to the last used folder where you posted the code to. And the file name is automatically set here. You can see that the file name is automatically set to the name of the file and the name of the setup. So we'll talk about the file naming conventions in just a moment. And the posted file extension is set to .nc, since we chose .nc as the posted file extension under set post processor options. And the current post, whatever we selected in the set post options dialog, is automatically set. You do have an option to change the current post in here at the time of posting. You can just select the drop down list and post it. And once you select post, the posted code will automatically appear in a notepad, which is the default editor. When you install RhinoCam or VisualCam, by default it's set to display the posted output file in a notepad. So we just posted a setup in here. A few things to note here is, for example, if you notice the work 0 and you have a part number or a program number. So since I have not set a part number or program number, we did not see the part number or program number being posted. So to add that, you just select work 0, right click, go down to properties, and you can enter your program number here. And now when I go back and repost the setup, I'll overwrite the same file, and you'll notice that the program number is output at the start of the code. Now we will talk about customizing the post and how to make changes to the post as we discuss through this webinar today. Now, we looked at post-processing the entire setup. If you have multiple setups in a project, you could select the machining job, right-click, and select Post All. So it's going to post all the setups, all the operations in each setup into a single posted output file. So selecting Post All will post both these setups. Now we are being notified that the machine tool does not have sufficient access to post-process. We will discuss this during the later part of this webinar. I'm going to go ahead and select yes to continue. I'll post it out. And you'll notice that both the setups are now posted. So the setup 1, and I can do a find for the next setup in here. And you'll notice that the setup 2 is also posted to the same posted output file. Now we could also post individual operations from a setup. You can select a single operation, right click and post. And you'll notice that the name of the file automatically uses the name of the part file that you have, plus it'll append the name of the operation name that you define in here. Now this is using the default naming conventions. So when you post a single operation, you could post multiple operations. You can hold the shift or the control. If you want to select operations 1, 2, 3, holding the shift key, you can select the first and the third operations, so it'll select all the operations. And you can right click and do a post. Or if you do a control select, you can select the operations that you would like to post. So in this case, it'll post roughing, pocketing, and deep draw. Now let's take a look at the posted naming conventions. Now that you noticed how we posted a setup, a machining job, and an operation, so you now have the ability to set automatically the file name, and you can apply certain naming conventions in here. So when you're posting an operation, a single machining operation in here, by default, it'll take the name of the file, the part file, plus the name of the operation. Or you could change this to just the name of the machining operation if you'd like. Or you could pick the name of the setup and the machining operation name. If I pick the setup and the machining operation name and post this operation in here, you'll notice that the file name for the posted file is setup plus the operation name when you post it. So under post-processor options for naming conventions, you can choose from one of these available options in here for when posting machining operation in a selected file. Now when posting an entire setup, by default, it is set to automatically use the name of the part file and the setup name. If you'd like to just output the setup name, you can change it to setup name. And when we post a setup, you'll notice that the name of the file just contains the setup name. Now when posting the entire machining job, which is when posting all in file, by default it's set to use the name of the file, or you could have it to use the name of the file plus the name of the first setup, or just the first setup name. So you have different options in here for the posted file naming conventions. Now, one thing to be noted here is when you right click and post, you could still change the name of the file to what you like. The default name, what it lists, displays here is what is defined in the naming convention. However, you can still change it to call it, for example, like it's say test1 and post it to assign your own name for the posted file. So just to summarize what we discussed here is we talked about how to set the current post processor, the folder where the post processor files are located, the posted naming conventions, and the posted file extension. The next feature I would like to talk about here is program to send the posted file to. Now by default, this is set to Notepad. What this means is when you post process a setup or when you post process any operation, your posted code is displayed in a text editor which happens to be Notepad. Now you could be using a CNC editor of your choice, or if you'd like to use it, output it, display the posted output file in a different program or editor of your choice, you could have it point to that application in here. So in this particular example, what I'm going to do here is I will have it output to a different program. I'm going to use a CNC editor. So I'll go into post and I can put in the folder path and the executable name of the editor I would like to use. You could also use the browse option in here to browse to that particular folder to locate that particular executable file, or you could just enter it in here. We could do a copy paste. And now when you go back and post process, your posted code will automatically appear in the editor that you chose. So rather than outputting it in to Notepad, you'll now notice that your posted file automatically appears in the editor of your choice. Now, for example, you could be sending it directly to your DNC. So you can just basically point to the executable of the DNC program that you're using. So you don't have to go into Notepad and then go into your DNC application and open the file. So you can directly send the posted output file to your editor or your DNC application of your choice. And this can be done in all our products.
One important note here, whatever program that you set up in that dialog, that needs to be able to take the name of the G-code file as a command line argument. If that executable does not accept the name of the G-code file as a command line argument, then all you will do is you will just launch that program and it's not going to read that file. But having said that, typically most G-code editors or DNC programs will do that, will take the file name as a command line argument, and so you should be fine. So in case you do run into this, that's probably the reason why it's not loading that G-code file. I hope that makes sense.
So the next thing we'll cover here is how to post-process a multi-axis operation. So we'll take a look at an example for 4-axis, and then we'll also take a look at a 5-axis. So we'll post-process a few indexed operations in here. So in this particular example, I have a part that's going to be programmed on a rotary axis like an indexer where you program the top face, you rotate the table by 90 degrees or 180 degrees to program from multiple orientations. So you're probably already familiar with how to define your machine tool for programming for 4-axis. Once you've done that and selected your post processor, you would be programming each orientation on a different setup using either rotate table setups. If this is going to be like an indexed operation, you would be doing rotate table setups. Now that you programmed different setups, you would want to post all of them out to your machine tool. So right click and select post all. We'll post each of the setups and it'll be part of the same output file, and you'll see that the first setup has your table at 0 degrees. The next setup would have the table at 180 degrees. So you'll see that in the code. So when programming indexed operations, you would typically want to post all of the setups into one NC file, so you don't have to go through the process of loading multiple output files and programming 4-axis operations in here. So you could select the machining job, right-click and post all to post all of the rotate table setups. Or if you just want to post a couple of the rotate table setups, you could just select each of the rotate table setups by just highlighting those setup folders in here, right-click and post. So you can selectively post, a couple of the rotate table setups, or the number of setups that you'd like to post process in here. Ideally, you would want to post all just by right-clicking and selecting post all. Now, a similar approach works for index 5-axis as well. So I'll go ahead and pull in a quick example for that as well. So here we have defined the machine tool as 5-axis. We've selected the post processor in here, the same workflow. And then we have 3 different setups programming the top. We have programmed the features on this inclined plane and a pocket operation over on the side face. So post processing the machining job, right click and post all. We'll post and output the rotations for each and every setup as you notice it in the posted code. So all of the setups are post processed. You have the setup 1, setup 2, where it outputs the rotation angles. And we'll talk about how these are set up in the post when we talk about the post processor generator in here. And then finally, we have the setup 3. Now again, when posting indexed operations, you could also selectively post one or more setups by holding the control key or the shift key to multi-select setups and posting. Now, if you like to post just one operation within a setup on an index 5-axis, you'd have to highlight the setup, and you'd also have to highlight the operation. So for example, if I want to post just the pocketing operation on this rotated orientation, I would highlight the setup and that specific operation in here, right click and post. So selecting the setup will output the orientation for the indexed orientation to rotate the head or rotate the table depending on how your 5-axis machine is defined, and it'll include the rotation of the primary and the secondary axis in your posted code. So you need to make sure you select the setup in addition to an operation if you're looking to just post one of the operations within a setup for multi-axis. It could be 4-axis or 5-axis operations. So just to quickly summarize here, we covered posting of 2 3-axis operations, 4-axis, and also 5-axis operation types. We talked about set post processor options, selecting a post processor, the program to send the posted file to, which can be changed to a program of your choice, and then the naming conventions for the posted output file and the posted file extension. Now we do have one additional option in here, which is show output dialog when post processing. So when this is checked, each time you post process an operation, it'll display the post and save as dialog. If you have that unchecked, it'll automatically post it to the folder where you last posted to. So it's going to skip displaying this dialog when you right click and choose post. You can also select that by saying do not show this dialog again, and when you hit post, the next time you post process an operation or a setup, it is not going to display the post and save as dialog again for you.
Yeah, it's going to use that the post naming conventions that you set up in the options dialog and write to that file name, and it will override a file if there is a file of the same name. So it's not going to warn you that a file of the same name exists. It's just going to override that file. So you got to be a little careful if you do that.
So the next thing we're going to cover today is post processor generator and preferences. So I will go ahead and switch back to the file we first started out with here. And let me go ahead and bring up the post processor generator. So as you go to the Set Post Processor Options dialog, you will notice that right next to your current post processor, you'll see an edit button in here. So selecting the edit button will display your post processor generator. Now this is one of the ways to display the post processor generator. You could also go over to Utilities and then select Post Processor Generator as well to display the Post Processor Generator. By selecting Edit from the Set Post Options dialog, will display the Post Processor Generator. Now the Post Processor Generator has several different sections in here, starting with the General section, where you can specify the file start reading character. So on several of the controls, they expect a percent or some sort of a symbol to mark the beginning of the G code and to mark the end of the code. So a percent sign is commonly used. So you can specify the start and the end reading characters in here. You have the mode for output, absolute or incremental, a G90 or a G91. So you can set these options in here. To output comments in your posted output file, you could enable comments to be output. So like for example, your name of the setup, name of the operation name will be output as a comment, or if you specified some comments under the tool, those will be output as comments as well. And then you have the option to enable sequence numbers. These could be like your line numbers N1 through 3 for each and every line of the code. And then you have the units that you can define. Your posted output file can be output in either inches or millimeters. Now your part could still be programmed in millimeters and you could be outputting it in inches. So the post will automatically take care of the scaling of your coordinates, your feed rates to the units that you've defined in the post processor. And then you have, we'll talk about the block format, the delimiter when we edit the post. You have the option to output leading zeros for the sequence numbers. So for example, instead of outputting N1, N2, N3, you'd like to output as N0001, 0002. You can enable show leading zeros and you can specify the number of digits for it. We will cover the modal output as well as we go through the webinar here. So the general section lets you basically set the parameters like the units, the comment, whether you'd like to output comments, the mode for the output, and the file start and end reading characters. Now the next thing is your start and end section. This is like your program header and the program footer in your G code file. So let me go ahead and post process the setup in here, and we'll put them side by side. And we'll take a look at it here. So now you'll notice that the percent sign, what we defined, is part of your general section. And we'll talk about how these variables are used in the post processor. The program startup section is like the header of your program. And you'll see that this information is right at the beginning of your posted code. The program end code is like the footer section. It's all the way to the bottom. And this basically is what you define in the end code gets output in the end of the program. Then the tool chain section is where you have the tool change information that's being output for your first tool and for all other subsequent tool changes in here. You could define multiple different lines. So for example, in this post, we have also output the name of the tool diameter and the tool length just as a comment, as an information. So it's easy for the operator to know what the diameter of the tool and the length of the tool is. You can also add additional information, like for example, you want to output the tool name that you defined when you define the tool in the CAM program. You can also have that added into the post. And then we output the tool number, the spindle information, and all of the macros are automatically defined in here. And I will go through an example of how to make changes to the post and how to edit this as we go through the webinar. So we have the first load tool macro. This is for the very first tool that's being called in the program. And then you have your next tool. So the tool change macro section in here is used for all the other subsequent tool changes, what information that needs to get output before each and every tool change. Now the setup information section is used for multi-axis. If you're programming a 4-axis, like an index 4-axis operation, the macros are defined, or the variables are defined in the setup for rotate table section. And for index 5-axis, the setup information is defined in the coordinate system change macro section. The spindle section allows you to set the spindle block format. So typically your spindle would be an S followed by a spindle RPM, and then the spindle direction, whether it's a clockwise M3 or counterclockwise M4, or you could be using MO3 or MO4 depending on what you prefer. So those spindle direction codes can be set in here, and the spindle speed and the macros are defined here. Now, you can customize the post by setting up your high and the low value that is suitable for your machine tool. So if your machine tool can go up to 25,000 RPM, so you may want to set your high value to 25,000 in here, because if you leave it as 10,000 and you program your machining operations with 12,000 RPM, the posted output will cap it to 10,000 because the high value was set to 10,000. So you may want to go back and recheck what the maximum RPM your machine tool is capable of, and then you can update the post for the spindle high and the low values in here. The next section would be our feed rate section. Over here you can specify the high and the low values for the feed rate, the decimal places for the feed rate, 2 decimal places or 3 decimal places. Now in our CAM product, the feed rates are defined as specified in units per minute. So it could be inches per minute or millimeters per minute. Now if your machine or controller is expecting the feed rate in units per second, you would have to change the scale factor from 1 to 1/60, so which will convert from units per minute to units per second if that's what your machine is expecting in here. And you can also set the decimal places. Now we have the option to output inverse time feed rates for multi-axis toolpaths like 4 and 5-axis continuous toolpath. You can enable that in the post. This would be typically like a G93 to enable the inverse time feed rate, and a G94 to toggle it off. And this can be set in the post processor for setting up inverse time feed rates. Now the units per minute and units per revolution code, this is typically used in turning applications. So you could specify that whether it's going to be a G98 or a G99. That is something you would be using in turning. This wouldn't apply to the mill module. Now the next section is the motion block format. This is where your rapid motion block and linear motion block formats are defined. So if in your programming you set your transfer feed rate to use rapid under feeds and speeds, this would be applying the rapid motion, which would be typically a G0 or a G00. That's defined under the rapid motion block format. And then the linear motion is your G1, linear like any cut motion, or if you set the transfer feed rate to a set, it'll be applying a linear motion and not a rapid motion. Now the rapid motion block can be split up into multiple lines. So for example, you'd want to do a Z motion first and then an X and Y. You can define it in here. Linear motion is typically output on one line. And then the decimal places can be set, like if you were outputting in inch units, you'd want to output as 4 decimal accuracy. If you're working in millimeter units, if the posted output file is going to be in millimeter units, you want to set it to 3 decimal, or you can even set it to 4 or 5, depending on the accuracy what your machine tool is capable of handling. So you can set the number of decimal places in here. The scale factor by default is set to 1 for X, Y, and Z on most of the post processors. So on certain machines, for example, like multicam routers, the scale factor for Z is scaled by -1. What that means is when you take a look at your program, your Z, typically when you set the Z0 to the top of your stock or top of your workpiece, any Z move cutting into the material would be a -Z, and this, as the tool moves up in the Z to the clearance, would be a positive Z motion. However, on a multicam router, a Z motion retracting from the origin up to the clearance would be a negative motion, and cutting into the workpiece would be a positive move. So you'd have to just do a scaling here by -1, and the post automatically takes care of scaling the Z values from a positive value to a negative value in here. So that's where the scale factors would be typically used. On most machines, it would be just 1, so you wouldn't have to scale it. But on certain machine tools like multicam, you would have to scale the Z factor by -1, and this is automatically set in our default post. If you go ahead and edit one of the other posts, you'll see it in the post processor. The circle section talks about how for circular interpolations, how we output arcs. So we have arcs can be output as, typically they're output as clockwise arcs as G2 or a GO2, counterclockwise arcs as G3 or a GO3. And then there's different formats in which arcs can be output: IJK radius, IJK only, radius only, and then the arc centers can be defined. Now, in our CAM program, if we go to preferences and machining, we have the ability to output arcs or output them as linear motions. By default, output arcs as linear segments is not checked, which means this is going to output true arcs. When you're programming, like arcs and circles, arcs are being output, and you can also fit arcs to toolpath in your program. So if you take a look at, for example, this roughing operation, these dark blue toolpath motions are arcs, and the turquoise colored motions are your linear motions. So if you have output arcs as linear motion unchecked, and if you also enabled arc fitting to your toolpaths, so arcs are being fitted to your toolpaths, and as you post process your machining operations in here, you will see arcs being output, and the macros, the variables, are configured in the post under the circle section. So in this particular post, arcs are set to be output as IJK only, and we are using incremental arc centers. Now, if I change the output to radius only, save the post, and repost this operation in here, you will notice that the arc format has now changed to X, Y, and radius format. So depending on what your controller expects, you can change the arc output format in your post processor. Now I will cover how the IJK values are computed by taking a simple example, and we'll talk about the arc centers in just a bit. So the arcs can be output in the 3 principal planes: the XY plane, XZ plane, and the YZ plane. And for each of these, the macros can be set up and configured in here in the post processor. Now, if your machine or control is not able to handle arcs in the X, Z, and YZ planes, you can go into your preferences and you can toggle these checkboxes off to not output arcs in the X, Z, and YZ planes and just restrict it to XY plane. Now we can also set the maximum arc radius. We can set it to the radius that your machine, depending on the work envelope and what the machine is capable of handling. So for example, I could change it to 100. And when I make a change to any of these preferences, I would need to go back and regenerate these operations in order for these changes to reflect. So you need to make sure that you go back and regenerate your operations before you post-process them out to your machine tool. So the circle section lets you define the macros for how arcs are being output and what are the arc formats. The next section would be helical spiral. A helix is basically helical interpolation inherits the same format that you have here for the arc centers for the helical motions. The difference between an arc and a helix is you have an additional Z parameter which creates a helix, and helical interpolations can be output in operation types like hole pocketing, hole profiling, and thread milling operations. Again, if you have output helix motions as linear segments selected, these would be output as linear motions and not as a helical interpolation. So you would need to uncheck this if you'd like to output helical interpolations. Likewise, the same works for spiral as well. So if you select output spiral as linear segments, they'll be output as just a combination of linear and rapid motions as opposed to a spiral interpolation where the macros can be set in the post. Now in this particular post, you'll notice that the spiral interpolation is not configured because this control probably does not handle spiral interpolation and may only handle helical interpolation. So you need to make sure that you have the output spiral motions as linear segments selected under your CAM preferences. If we uncheck it and post-process, you wouldn't see any code that's being output for a spiral motion in the posted output file. The multi-axis section is used for configuring 4 and 5 axis outputs, where you can define your primary, secondary axis, and the rapid and the linear motion blocks for it. The cutter compensation section is where we define the cutter compensation left, G41, G42, and cutter compensation cancel. We'll talk about the cut motion start and cut motion end blocks. This is typically used when you're outputting it for like a plasma machine or a laser machine, or even on a multicam where you need like a certain M code that needs to be output before the start of a cutting motion and at the end of each cutting motion. These can be defined in here, and I'll go through this when I take a look, when we look at a programming for a plasma or laser operations. The next section would be the cycles. This is where you can define and configure all of your cycles for hole making operations, like a drill operation, standard drill, which is a G81, a deep drill could be a G83, brake chip cycle or chip brake cycle, countersunk, tap. So these are configured right in here for the different cycles that are in your post processor. Now, if your controller does not handle any of these cycles, there is an option to output them as linear motions. And this can be done basically by selecting always output as linear motions under CAM preferences. When you select this and you post any of your drill operations, these would be output as linear motions and not as CAN cycles that are defined in here. So in this particular example, the one I posted, you will notice that there are several different drill cycles that are being output. You'll see that a G81, which is a standard drill cycle that's being output, and then you have a G83. Since this controller handles drill cycles, you can output them as drill cycles as opposed to outputting them as linear motions. So if you go into CAM preferences and choose output as linear motions, those would be output as simulated cycles or just as a bunch of linear motions using a combination of G1s and G0s in the posted code. So we briefly talked about the post processor in here. We talked about the different sections of the post processor. The last section is the miscellaneous section where you can set the coolant codes for your coolant flood, mist, through, and also the work offset prefix in here. Now what I'm going to do here is talk about how we can edit and customize the post processor, and we'll go through this section here. Now let's say, for example, we would like to go ahead and add the extent of the stock that we've defined as a comment in the posted output file. So I would like to output the stock length, width, and the height in the posted file. At the start of the program, maybe I would like to have it output after the program number. So in order to do that, we would go into the post generator, go to the start and end section, and we will insert a new line by just pressing enter. And I would like to output the stock length parameters in here. So I'm going to first use right click on it, and this brings up the list of variables that are in your post processor. You can just basically scroll through the list and insert it. So first I'm going to insert the sequence number, which is the line number which outputs n and then followed by the number. So I'm going to use sequence pre-character, so which outputs the pre-character, which is the letter n. And then I'm going to insert the sequence number, right click and select sequence number in here. Or you can even type it in. So you can basically just scroll through the list, select it in here, and then I would like to output the stock as a comment. So I'm going to insert a parentheses. I'm going to say stock. I'll just type in the word stock dimension. I could say X equal to, and then right click on it again, and I'm going to go locate the variable for the stock length. So if you scroll down the list, you'll see there's variables for stock length, and there's a description for each variable. So I'm going to pick stock length X. I'm going to repeat the same for the stock length Y. So I'll just highlight it just to make it faster. I'm going to do Control C for copy, Control V for paste, and just I'm replacing the X with the variable Y. I'll do the same for the variable Z here. And I'm going to close the parentheses in here, and I'll save the post. So now if I go back and repost the setup in here, you will notice that right after your program number is output, you have the stock dimensions being output in your posted code. So you have your X, which is the units that you have it output in inches. 16.5 inches is the stock length in X, Y, and Z. So we were able to modify the post to insert some additional information. Now with the program encode, you may also want to add like an M09 or M5 to turn off the spindle. You can make a copy of this existing line, just insert a line, do a paste using Control V, and you can always go back and change and add additional information in here, and select save to save the post processor. I would recommend using save as and save the post under a different name. So you know that you made a change, you modified an existing post and saved it in a different name. So in case you want to revert back to the default post, you always have a fallback plan to go back to the original post. So just use save as and save it under a different name rather than just overwriting the default post that's included in here. So now that we made a change to the program encode, post-processing the setup again will include M5, M9, and M30 in the post processor. So you could make changes under each of these sections in here. One caution here is if you make a change and if you make a typo in here, for example, I delete one of the closing brackets in the variables that are in the post, and when you repost it, you'll notice that the posted output file will have an error. So you got to make sure you don't make an error. If you make an error, you can see that the Y variable value is not being output. Instead, it's outputting the part of the macro itself because it was not fully defined correctly. So we want to make sure that we don't make any errors or typos. Just go back and fix them, or you can right click to insert the variable if you feel comfortable by inserting it rather than typing the variable names. So once you make a change, you repost it, you will see the posted output file now shows the Y coordinate value that's being read from the program. Now let's take a look at how we can insert, make use of arithmetic expressions with the post processor and how we can apply them into the post. So I'm going to switch back to this PowerPoint slide for a moment here. And just to give you a quick overview, what arithmetic expressions and how you can use them in the post. So you can use operators like plus, minus, divide, multiply, square root. You can use these operators in combination with your variables. Now, for example, let's say at the start of your program, you would want to move the tool to a certain height above your clearance height. So if your clearance is a 1/4 inch, you may always want to go an inch above your clearance. So we can use the arithmetic expressions in here to make sure that the tool always stays an inch above your clearance. So you don't have to hard code in a specific Z value in the post. You can actually use it, a combination of using one of the variables in the post with an arithmetic expression. So these are the rules in here. You can basically make sure that the expressions are entered, placed in the tags with within the brackets and with marks the beginning with an E and ends with an E for expression. You can specify negative values that needs to be in parentheses. parts of expression can also be placed in parentheses. You can use, instead of fractions, you want to use them as a decimals. In here, like 0.125, instead of typing a quarter of an inch, you type in 0.25. And you can also, have spaces. Those will be removed while it's being parsed. And then numbers can be entered either as 0.9 or as 0.9, for example. So we will go ahead and insert a expression into the post in here. So let me switch back to the product. Let's go into the post processor generator. I'm going to pick edit, and I'll go into the tool chain section. And you'll notice over here, we have a Z value that's being output in here on the line G43. So rather than outputting the clearance height that's being output in the posted code, so if I go take a look at the posted code here, you'll see that the Z value is 0.25. I would like to make sure the Z always stays an inch above the clearance height at the start of the program. So I'm going to use the expression in here to make the change. So I'll use the expression. I'll begin with the E, and I'm going to open the brackets for it. And then we have the variable in here. And I'm going to add 1 inch to it. So I'm going to say plus 1.0, and then use E to mark the end of the expression. And I'll close it with the bracket parentheses. So I've defined it for the line G43, where the Z value needs to be 1 inch above the clearance height that's being computed. And I'm going to apply the same. I'll just do a copy and a paste for every tool change, subsequent tool change as well. So I did a copy and a paste. We'll do a save in here. So now that we made the change and saved the post processor, I'll go back and repost it in here. And you'll notice that now in the posted code, your Z value is now 1.25. So it has added the 1 inch that you added to your clearance height. So it's always going to be clearance height plus 1 inch. And this would also apply for all your tool changes as well. So if you look at a tool change, you're seeing that the Z value is 1.25. If your clearance height was different, then it's going to be different on the subsequent operations. So this is how you can use arithmetic expressions with the post. You can also use a combination with different variables as well. So I just gave you an example in here. So just to summarize what we talked about in this section, we went through the different sections that are available in the post processor. We talked about how you can insert variables into the post processor and also use arithmetic expressions with the post processor and how this reflects your output in the posted output file. Now the final section we're going to cover today is some of the useful tips and tricks in the post processor, and I'm going to cover that here. So one of the useful tips and tricks I would like to talk about is being able to output a coolant in the code at a specific location. So for example, if I set the coolant type to flood in this operation and I post process the toolpath, you will notice that the coolant code, the M8 for flood, is output by default after the first rapid motion. However, if you prefer the coolant to be output before the rapid motion, or right after the tool is selected, or if, right after the spindle RPM is being output, you can go into your post processor, edit the post, and our tool chain section, you can insert a variable to have the coolant output before the first rapid motion. So you can use this coolant code insert variable, and this will output the coolant code before the rapid. So you can place it even before the spindle block is called, but typically you'd want to have it output right after the spindle is called, so you can change the location. You save it in the post processor. When you go back and repost it, you'll now notice that the M8, the coolant code, is output before your rapid motion. So you can choose where you want the coolant code to be output. Certain machines require the coolant to be output so there's enough time for the coolant to kick in before you do the first rapid move. Now also, if you notice in this particular program, there are several drill cycles being output in here. So when I post the drill operations, I'll just select these two drill operations and do a post. And for each hole that's being drilled, you have a G81, and then it cancels out to the G80, and then rapids over to the next hole, performs a drill cycle, and cancels it out. The same thing applies for a deep drill as well. One of the options we have is what's called an optimized drill cycle output. So when you enable the optimized drill cycle output in your post, and this can be done by editing the post processor, going down to cycles, and you can select optimize cycle output. When you save it and repost your toolpaths, you will notice that the drill cycle is only output on the first hole, and then for the subsequent holes, it just outputs the X and Y coordinate values. And once all of the holes are drilled, it cancels out the drill cycle with a G80. So it just makes your code a lot more efficient, simpler, easy to read, and you can enable the optimized cycle output. You'll notice that for the deep drill cycle as well, it applies automatically. So you have your G83, which calls out your deep drill, and then you have your subsequent X and Y motions. Now the next thing we're going to look at is how can I insert certain machine-specific codes between operations. Now consider that between the roughing and the pocketing operation, we do not have a tool change. However, I would like to do an optional stop between the two operations. So there's a couple of ways we could do it. The easiest way to do it is you can right-click on this pocket operation and then go to properties, and you can specify a comment that you'd like to output. So for example, if you want to output an M01, you can type in as a comment to output. However, this is going to output as a comment with the parentheses in the posted code. So if you want to skip the comment characters, you can add a dollar symbol as a prefix to it. And now when you go back and repost it, I'm going to select these two operations and post them out again. And you'll notice that when you go to the next operation, before the start of the operation, you have the M01 being output in here. Now this is one of the ways how you can output certain instructions as part of your code in the posted output file. The more streamlined way of doing this would be to use what is called a machine control cycle. So if you can go to create miscellaneous operations, you can go to machine control and you can pick any one of these cycle types and you can configure the cycles in the post. So I'm going to choose cycle 1 in here as an example. I've inserted a cycle. Now I'm going to go into the post processor, edit the post. We'll go down to cycles, and I'm going to go down in the list and pick machine control cycle 1. And I'm going to insert the code M01 in here. Or I can say, for example, M00. You can have one or more lines of code specified in here. We'll save the post processor. And then when we repost it, you'll notice that the machine control cycle is output. It'll output the instructions that you put in the posted code. So you can use, there's 4 different cycles. So if you want to have 4 different types of machine control outputs that needs to be set up, you can do this in your post processor. One of the other things I would like to talk about here is how we can use the cut motion start and cut motion end variables in the post. Now I have an example here for a 2D operation, which is typically used in like CNC plasma tables or CNC lasers, where you would need to output a certain M code before the beginning of a cut, and then at the end of a cut before it transfers over to the next region or the next part, you want to turn off the torch or you want to turn off the laser. So that's typically done using like an M code in your post processor. So as you go into the post and edit the post processor, you will see that there's a section called cut motion start and end, and you can define the variables for that, the macros in here. So in this particular example, an M61 is used to mark the, enabling the torch on the plasma to begin cutting. And then before you do a transfer, you want to use an M62 in here. So now when you post process these operations, you will notice that it outputs an M61 and an M62. Now the M61 and the M62 here are being output after the entry move is being performed, after the entry and exit. Now if you'd like to output this right after the right before the plunge motion, you can select this checkbox under the linear motion section of the post processor. And now when you go back and repost it, you will see the M61 and M62 will be output right after your rapid motion in X and Y before the plunge. So there's an M61, and then you have your cutting motion, which could be a combination of linear and arcs. And then you have the M62, which basically turns off the torch, or if it's a laser or a water jet, you turn it off, and then you wrap it over to the next XY location, and then automatically enables the M61 in here. Now the same thing can also apply to a multicam router where you need to do like a 3D device on and off using like an M12 and an M22. So instead of M61, you would be defining this as M12 and then M22. So depending on what your machine expects. So folks, these are some of the useful